Welcome back. Welcome back to the part two of solving integration problems. Um, this second part has to do with solving definite integral. The first examples I gave in part one has to do with solving indefinite integral. Indefinite integral. We're talking about definite integral now. Definite integral now, or integration. Now, if you are given a function like this, and for instance, we can call this example one for definite integral. If you are given a function like this, simply like this, plus 3x dx. If you are given a function like this to integrate, like I said, the first assumption here is that this is going to be an indefinite approach. What makes it a definite approach is when upper and lower limit is introduced. For instance, 3, 1. So with this now, we are going to use definite approach. And what makes it different from the indefinite approach is that we are going to substitute the upper limit for x while integrating, and you also in one part, and you also substitute the lower limit for x while integrating on the other part, and then you find the difference between them. In other words, what happens is that you end up doing something like this: upper limit minus lower limit. That's what you end up doing. So from this function, this is what will happen. So let's try to solve this now. This is what will happen. X raised to the power 2 plus 3x dx. This is what will happen. You're going to introduce a bar with the limits captured properly, and you will start your what do you call it? You start your integration, and you're going to introduce a limit, and you have something like this. X raised to the power 2, because the power is 2, plus 1 all over 2 plus 1. As usual, you bring down the increased power, plus, as this very plus, you do the second one, 3x raised to the power 1 plus 1. Then you bring down the 1 plus 1. But here, you do not introduce a c. Here, you do not introduce a c. Then, this will give you maintain the limit signs. This will give you x raised to the power 3 all over 3 plus 3x raised to the power 2 all over 2. This is the integral value of the function that we're given. Now, what you now do with the limit is to substitute it for x. You substitute the upper limit for x on one side and substitute the lower limit for x on the other side. You can do them simultaneously, you can do them separately. just so you do not make mistake. So while using the upper limit, which is 3 now, this is what you will get. You will have 3, which is x is now 3 raised to power 3 all over 3 plus 3 into 3 raised to power 2 all over 2. This is on the one side. You can put all of this in a big bracket, solve it separately. You can do it like this, is better. Minus the lower limit. Open another big bracket. Now the lower limit is 1. So you put 1 in anywhere you see x, which is 1 raised to power 3 all over 3. You're still repeating this same function, bringing all these functions, but this time around replacing x with 1. So plus 3 into 1 raised to power 2 all over 2. Now, I would recommend you solve everything in the brackets, solve them separately because of the problems that may arise while you are trying to manipulate your signs. But if you are good, you can just leave without bracket and solve straight away. You know that this plus sign here, you know, eventually will turn to negative sign. So if you are already, if you can handle that properly without making mistake, then you don't need all these brackets. Otherwise, you do. So by the time you start calculation, 3 raised to power 3 will give you 27 over 3. 3 raised to power 2 is 6. Sorry, is 9. 3 raised to power 2 is 9. 9 times 3 is another 27. It's another 27, please. If you are not too strong in manipulating signs, inequality signs, please remain in the bracket. And you open this again. 1 raised to power 3 is 1 all over 3 plus 1 raised to power 2 is 1 times 3 is 3 all over 2. Remain there. So it's becoming much simpler. In here, there is a lowest common multiple of 6. Lowest common multiple of 6, which is the least number that can be divided by 2 and 3 at the same time. So now you can draw your line. 6 divided by 3 is 2. Now that 2 multiplied by 27, you have 54, plus 6 divided by 2 will now be 3. That 3 multiplied by 27, you have 81. You have 81. Please, you can still remain in your bracket. You do the same thing here. 6 is still the LCM. 6 divided by 3 is 2. 2 times 1 is 2 plus 6 divided by 2 is 3. 3 times 3 is 9. You can remain in your bracket. So then, what happens next is that you add up the numerator, and that will give you 100, and this plus this is 5, and then 8 plus this is 13. 135 all over 6. Then you can forget the bracket issue. Now this plus this, 2 plus 9 is 11 all over 6. So of course the LCM here is 6. You understand? So 6 divided by 6 is 1. 1 times 135 is 135 minus 6 divided by 6 is 6. Sorry, it's 1. 1 times 11 is 11. So at the end of the day, you are going to have take one here 4, take one from here 2, then bring down this one all over 6. So when you do this division, what you are going to have is 20.6. 20.6666 and so on. So this is what you are going to arrive at. You've just successfully solved the okay. Like I said, let's try another example for the definite integral. Let's try another example. So let's say you are given this x raised to power 2 plus 2x dx, x raised to power 2 plus 2x dx. What it will give you is this. You integrate the function first, x raised to power 2 plus 1 all over 2 plus 1 plus 2x raised to power 1 plus 1 all over 1 plus 1. Of course, this will give you x raised to power 3 all over 3 plus 2x raised to power 2 all over 2. You can decide to cancel out this, or you can decide to leave it. But for simplicity's sake, you can just leave it, just to make it a little bit simpler for you. You leave it. Then what do you do with the limits? You introduce them to the integral value you got here. Introduce the upper limit on the one side and the lower limit on the other side. So what do you have? Let's use the big bracket as usual. You have 4 raised to power 3 over 3 plus 2 into 4 raised to power 2 all over 2. Close your big bracket minus, repeat the same process, but this time around put 1. So you have 1 raised to power 3 all over 3 plus 2 into 1 raised to power 2 all over 2, and you close the bracket. Then now you can expand. You can 4 raised to power 3 will give you 64 all over 3 here. Then 4 raised to power 2 will give you 16. 16 times 2 will give you 32 all over 2. Do not rush. Just take it gently so that you do not make mistake. 1 raised to power 3 is 1 all over 3 plus 1 raised to power 2 is 1 times 2 is 2 all over 2. Please, you can still leave it this way so that it will make your calculations easier. Now, of course, the concept of LCM will come again. You have 3 and 2, which will still be 6. So you can do this now. What do you have? 6 into divided by 3 will be 2. 2 times 64 will be 128. That is 2 times 4, 8. 2 times 6, 12. Then plus 6 divided by 2, 3. 3 times 32 will give you 3 times 2, 6. 3 times 3 will be 9. So please, you can still put them in the bracket. Then you come here, you use the same 6 as the LCM. 6 divided by 3 will give you 2. 2 times 1 will be 2 plus 6 divided by 2 will give you 3. 3 times 2 will give you 6. Then you close the bracket. So at the end of the day, you do 128 plus 96. That will give you 224 whole over 6. Now you can leave your bracket. 2 plus 6 give you 8 whole over 6. So now you have 6 as the LCM. 6 divided by 6 will be 1. 1 times 224 will be 224 minus 6 divided by 6 will be 1. 1 times 8 will be 8. So when you do 224 minus 8, it will give you 216 all over 6. So what happens at the end of the day is that you divide 216 by 6, and that will give you 36. This is your final result. This is what you will get. So thank you for watching this video through. Don't forget to like, don't forget to share, don't forget to subscribe, don't forget to drop comment, observation, and so on. So while I continue to make effort to bring more videos like this, I'm also working on improving the quality. Hope you enjoy visiting my channel. Thank you very much, and see you next time.